Hi everyone, I hope you're having a wonderful fall break. Today I'm doing an experiment for lesson 4.02, temperature and chemical changes. We learned back in lesson 4.01 that temperature can affect a physical change. This experiment is to find out how temperature affects a chemical change. So what I have here is 3 cups of water, and I've already done their temperatures with my thermometer. The first water is the cold water, and that's 41 degrees. The middle water is the room temperature water, and that's at 75 degrees. And our hot water is at 176 degrees. So our test variable is the water temperature. That's the thing that's changing during this experiment. Our outcome variable, what we're trying to figure out, is how fast the Alka-Seltzer antacids will dissolve in the water. And then our control variable is the amount of water and the size of the cups and the size of the Alka-Seltzers. So this is Alka-Seltzer antacid. You take this when you have an upset tummy. I've never taken this in my life. I usually have a cup of tea and some saltines, but now I have a lot of Alka-Seltzers, yay! All right, so your question, how does temperature affect the chemical change of an antacid tablet when placed in water? Your hypothesis, if the temperature is, you choose, hotter, colder, the Alka-Seltzer will dissolve, you choose faster, slower, okay? So I'm gonna go ahead and pop these in here and then start my timer and we'll see what happens. So there used to be a commercial, plop, plop, fizz, fizz, oh, what a relief it is. Here we go, ready? Boop, 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 and start. All right, so I see a lot of fizzing happening over in the hot, kind of some fizzing happening here in the room temperature. And notice the cold is the only one that sank to the bottom. All right, let's see how fast. This one is going so fast. And it is done at about 20 seconds. Done at 20 seconds right here in the hot water. We're still happening over here. And in the room temperature water, it's still a little bit happening. What is going on here? It's got a little bit more left, a few more seconds. And it is going to be declared gone at 52 seconds in the room temperature. And now we've got the cold going. It's past a minute. So we went from 20 seconds to 52 seconds. And now we are past a minute, and oh, it has started to float up the cup, and now it is floating on top. And we will be looking at it being gone. I predict sometime in this next minute, before it hits 2 minutes, we shall see. So we are still a little clump of the Alka-Seltzer left there. And taking its time here, taking its time. These other two look pretty identical, but this one, quite a bit of bubbles. And I would say it is taking past 2 minutes. Still a little clump of the Alka-Seltzer left there. It is just about, let's call it, we will call it gone at 2 minutes and 15 seconds. So good job on that. So our conclusion is going to be then that the temperature of the water, the hotter the temperature of the water, the faster the Alka-Seltzer dissolved, or the faster the chemical change happened. So cheers.